Okay, and recording. So this support workshop was inspired by a couple of tickets that have come through regarding what kind of tools we distribute. So this is things like the AWS CLI, Azure CLI, Kubernetes Helm, things like that. And so what versions do we supply? Under what conditions do we supply them? How are they updated? What's the best practice? What's recommended? And how do we actually diagnose people's issues when they run into trouble with these particular tools? And so in preparing this, I realized there's actually a wide variety of combinations and permutations of the different processes or procedures that we've been through over the years to distribute tools. And it can be a little bit complex to understand or to work out exactly what tool has been run where. So hopefully at the end of this, everyone will have a better idea. So a little bit of history. Back in the beginning, Octopus, a lot of the steps, and certainly all of the cloud steps, only really supported run on server. So if you go in here, the execution location was the server, and the server was obviously Windows. So we could safely make the assumption that if you were running cloud steps, you were doing so on Windows. And so the first Azure steps made the decision to distribute the Azure CLI and the Azure PowerShell modules. And so what this meant is you could fire up one of these Azure steps and be certain that the tools you needed to interact with Azure, and certainly the tools that Octopus needed to interact with Azure in terms of the login commands, would all run. And so things got a little bit more complicated when we introduced workers, because now all the run on server steps could actually be run somewhere else. And that somewhere else could have been a Linux or potentially a Mac OS box. And suddenly this, the realization that we could just ship Windows tools was false. And suddenly we were faced with the prospect of shipping the AWS CLI, the Azure CLI, the AWS PowerShell modules, and the Azure PowerShell modules across 3 operating systems. So suddenly the surface area of these tools began to explode. And so what we made the decision there to actually not ship any tools for Linux. This just started to get too much to manage. The upgrade process for people was kind of cumbersome. Like you have to update Octopus itself to potentially get the updated version of the tools. The tools themselves weren't being updated regularly anyway. I think we were hesitant to do that because potentially the new versions of the tools would break existing deployments. And we didn't really have good insights into what those breaking changes might be with tests. So we've tended to leave the version that we know works unless there's a significant reason to change. But the distribution of these tools is still in place. So if you look in your tools folder under the Octopus server directory of the Octopus install, you can see these directories here, and these are all the tools that we have shipped to Windows. And you can see here's the AWS tooling, here's the Azure tooling. Java's a bit of a special case. This is actually an application we have written ourselves to serve as the interaction point between Octopus and the Java application servers like Tomcat and Wildfly. So this is not, I mean, it's distributed as a tool, and this is one of those cases where we do distribute tools to Linux, but this is not an external tool. This is something we've written ourselves. And then we have the Terraform CLI, and this is another pain point here. The versions of Terraform have caused us a few support issues in the past. So what we realized then moving forward was that distributing these tools just wasn't going to work. Like it wasn't a scalable solution. And for steps after these cloud steps, steps that were developed after these cloud steps made the decision not to ship anything. And so that includes things like Helm and Kubernetes. We also have the service fabric steps, and they require the service fabric SDK to be installed on either the Octopus server or the workers that will be running the step. So we also don't distribute that. I think that was more a decision made around the difficulty of distributing it rather than a desire not to distribute it. But the end result is if you're running service fabric, you need to install the SDK for yourself. And then we introduced Octopus Cloud. And one of our goals for Octopus Cloud was to have an environment that people could basically jump into and just start deploying things without having to prepare workers or install tools. And indeed, in a lot of cases, people couldn't install tools on the local Octopus server. Octopus v1 was a lockdown VM. Customers didn't have access to it. And Octopus v2 is now a Kubernetes cluster. And I mean, there's just no facility there to be installing custom tools alongside the Docker image that's running Octopus itself. So the solution here was to have dynamic workers. So these are just workers that are spun up on demand. And the initial dynamic workers were Windows 2016 based. It's only recently that we've introduced the Linux workers. Though the 2006 workers have been around for quite some time. And they had a whole bunch of tools. So what you'll see here is that we've installed Helm and kubectl for Kubernetes and a bunch of other useful things. So here's the Service Fabric SDK that people would normally have to manually install. A few other things like Octopus Client. And so again, this solved a problem of people having convenient access to tools, but it introduced just another set of tools and tooling versions that we had to manage. And again, they were hard to update. It just became tiresome, I guess, or it was difficult, I guess, to manage the updates of these and to make sure that everyone had the same experience and that all their existing deployments would continue to work. And so you'll notice actually a few of these are quite old. Helm is up to version 3, kubectl is up to 1.19, I think. So a lot of these tools have actually are now quite old. And then moving forward, recently we've introduced 2019 worker images. And you'll notice actually a lot of these versions are exactly the same, even though they're old. The decision here was that we wanted to make the 2019 worker images as much of a drop-in replacement for the 2006 ones as possible. So all the versions have been kept the same where that made sense. We also had the Linux dynamic workers, and you'll notice there's almost nothing installed on them. You get .NET Core, you get the ability to run Docker. We've added PowerShell for running your PowerShell scripts, and Python 3, which would allow you to run the Python scripting language if you've selected that on your scripting steps. So this is a bit of a conundrum, right? Like, how do you know what tool someone's actually running when there's so many different tools either pre-installed or distributed by Octopus? And to manage this kind of matrix of tools, we realized we needed something new. Like we needed a new solution because pre-installing these tools just was never going to scale, and we could never please everyone with the particular versions or the particular applications that we were installing. And that's where execution worker containers came in. And so what these are Docker images, and the when you select them, for an example here, so you can select a Docker image, you can select a specific version of the Docker image, and these are immutable, so we don't overwrite the tools that go into this particular version of the image. We'll always publish a new one. And when you actually run these steps, what happens is Calamari will create a Docker container based on that image. It will mount the directory, the working directory of Calamari into that image. You can actually see that command being run here, right? So Docker run, it's going to run the particular image that we listed on the step. It mounts the directory. So this is the working directory of Calamari, and it mounts that into the Docker container, and then it executes Calamari. So the end result of all this is that the Calamari is essentially being run inside of this Docker container, and because it's being run inside of it, it gets access to all the tools that we have installed in this particular version of the container. And so this solves a lot of the problems. We can provide updated containers, but existing customers still reference this container. I should point out, this container doesn't get updated. It's not selected during the create release process. You actually set the version inside the step, and it's fixed, and it doesn't change unless you manually change it. So if we go back here, you can see the version is set here, and that's going to be fixed and it won't change. And so what that means is we can update the versions of the tools. We can release 1.07, but anyone using 1.06 still continues to work, and they get the versions that they want. It also means that you can create your own Docker images if you want. So you can either base your Docker image off ours and install custom tools, or you can actually just go and use the Docker file that we've created, and that is in an open source repo. So if we look here, you can actually just copy and paste this and customize it however you want, and you'll end up with an environment with your particular tools at your particular version. So I guess there's now 4 different ways that you can get tools into a step. And so the first one is that for the Terraform, Azure, and AWS, when running on a Windows worker or running on the server, Octopus will send down a version of the CLI tools and optionally the PowerShell modules for the AWS and Azure in this case. There's no such thing for Terraform. And so you get those, they're put on the path, and you kind of don't have to think about it if it works. But if it doesn't work, then you'll have to look at another way of getting those tools onto your box. If you're in cloud, the Windows dynamic workers come with a reasonable selection of tooling. But again, if these versions don't suit or not quite what you need, or you need additional tools, then you need to look at another way of getting those tools onto the box. The third way then, and this is the way that I think this is the solution that we'll be pushing going forward, and it's certainly evident by the fact that the Linux dynamic workers come with very little tooling pre-installed, is to use the worker images here. And so this gives you the stability of an unchanging environment if you want that, the ability to upgrade if you do, and the ability to customize if you really need that level of control. The only downside here is that the 2016 dynamic workers don't actually support containers. You can only use these worker containers on 2019 or Linux. And so the fourth way, and this is step specific, it hasn't been implemented in many places. But if you look at a step like Helm, for example, they do expose the ability to use to execute Helm from an executable inside a package. And so what you'll often find here is that, for example, if you've moved to Helm 3, but you've used the dynamic worker and it's only got Helm 2, what you'll do is you'll actually upload Helm 3 as a package and then reference it here. And that way the package is downloaded and extracted onto the target. And then the Helm executable from that package is used. And that gives you control over the particular version that you're using. The other thing you do is obviously just install it on the worker itself and point to the path here. Let's have a look. I guess another way you could tackle a lot of these things is using reference packages. I've done this for, like, if I need something like curl, for example, on a Windows box that doesn't have it, I can download the curl distribution for Windows, install it as an additional package reference. Install it, just upload it as a package and then reference it here as an additional package reference. And then once it's extracted, I get access to that package in my script step. I can call it directly. And that's another way of getting tools onto a box that we either don't supply or don't support. A lot of the cloud steps come with this option here. So this is, again, kind of an understanding that the tools we provided are often, or almost always, going to be not up to date with the latest version. And if you don't want to use those bundled tools, you can set an option like this, and that tool bundle won't be downloaded and extracted, and instead it will just defer to like a pre-installed copy that's globally available on the worker itself. So this is a way of preventing the version from Octopus being sent down and using your own custom version that's just installed locally. And this means you don't necessarily have to use a container if you don't want to. So one of the questions then is, what actual version am I running? How do I know? And I think from a support point of view, given the combination of possibilities here for the different versions we either distribute, the different versions on the work images, the possibility that they're using containers or deferring and using their own tools installed on a worker, it's usually going to be important to understand what the actual version of the tools are. And so most of these tools come with a version command. So this is Azure here, and that will give you the version of the cross-platform Azure CLI tooling. Again, this is running on a Windows. This will run on a Windows dynamic worker. So I've run AZ get version. I've also run get module. This just shows the location of any modules that we've installed. And in this case, it shows the location of the Azure PowerShell modules that we've distributed that have been sent down by Octopus to the worker. AWS, similar thing, AWS -- version. This is the cross-platform executable. Azure also gives you AWS also gives you this particular command to dump the versions of the PowerShell modules. So that's quite useful. I couldn't find an equivalent for this with the Azure PowerShell modules, but this is quite powerful. The only difference here is that I'm running on an Ubuntu dynamic worker, so the PowerShell modules aren't installed. But in this case, we can still get the AWS cross-platform CLI tool, but only because we've used a worker image here. If I hadn't done this, this would fail because those Linux dynamic workers have next to nothing installed on them, and they certainly don't have the AWS tooling installed on them. So for things like kubectl, you just run kubectl version. Helm, you just run Helm version. Just be aware that the Helm version, unless you've actually set up a correct Kubernetes config, This takes a couple of minutes as it tries to reach out and talk to the server, but the server doesn't exist because it's never been set up. It kind of looks like this has stalled, but it is working. It will get there eventually, which I think we can see that in the test run that I did here. If we go here. Right, so it's probably 5 minutes or so. It sat there and waited. So at first I thought this crashed, but yeah, if you run Helm version, just be aware that it can take quite a bit of time to get the tools that it needs. So what are the takeaways, I guess, for supporting all these tooling options that we have? I'd say first, it's best not to assume any particular version of a tool. It might be tempting to just do something like this locally on your own test instance and find out that you're getting version 1.16, for example, and go off to AWS and see what bugs have been fixed in 1.16. But actually, as we've seen, the AWS CLI can either be distributed by Octopus, it can potentially be installed on the server or worker, and the customer has selected not to use the version distributed by Octopus. It could be the version on the dynamic worker. It could be a version on a Docker image, or they could have even just potentially uploaded the CLI as a package, like we do with that Helm executable, and gotten around it that way. So there's many different ways people can get this executable, and the version that may not be clear in the support ticket. So it's always good to get that particular version. The second takeaway is that Octopus is very much moving away from providing tools in the main product. I don't foresee any new step being introduced that will distribute tools in the way that AWS and Azure distribute the tools. The way forward is almost certainly going to be more custom Docker images here, and that way we get the advantage of versioned tools and custom tools if customers want to do that themselves. The other big takeaway is that no Linux or Mac OS targets or workers will ever get tools. The possibility of running steps on Linux and Mac OS workers was the breaking point for Octopus to just say, we're not distributing things anymore. And so that does mean that there's a difference between running this step here on a Windows worker, because I know that Octopus will at least give me something here, and running it on a Linux worker. I can't assume that Octopus is going to give me anything. Either the worker itself needs to have that installed, or I'm going to have to look at something like these container images here. And that's true both for any of your own hosted workers and for dynamic workers. I don't see any Linux workers getting anything more than this. And actually, I suspect any new Windows ones will actually start paring this list back. I think the route will go down will be to have as little installed as possible on a dynamic worker, and instead leverage those container images. But the other thing to be aware of is that the 2006 images, which are the default today for any new instance or any new worker pool, don't support containers. They just don't have Docker installed on the 2006 dynamic workers, and I don't think they ever will. This will be only something available from 2009 moving forward. So that's all I wanted to cover there. I know it was a lot of information and a lot of, it's kind of a big matrix you have to keep in your head. Anyone have any questions or want to dive into anything in particular?
Yeah, is there going to be a way to surface more information in the task log? Like, could we write out a lot of these versions, at least in the verbose task log? Because currently we have to have them run the version command to reference, but I mean, it might be a lot quicker from a support perspective to try to surface more of that.
Yeah, that's actually an interesting point. I guess if you could. So for these steps here, what do you get? I don't think you get anything. Yeah, it's not a bad idea.
And especially since it's going to be a lot more customizable going forward.
Yeah.
It feels like it's going to be more important.
So I think what you will find is that when we install things like the PowerShell modules, there is this debugging message that shows you how long it took to get, how long it spent to import a module. And from here, you can tell the version. So you can,
Yep.
if they're using PowerShell anyway, you get that. I don't think you're going to get it for the cross-platform tools though. So that's, yeah, I can see how that would be useful. Yeah, something to keep in mind. I don't know, we have plans to do that now, but it would certainly be a useful support tool.
Yeah, cool.
All right. Oh, well, if there's no other questions, then thanks for listening, and I'll put up the recording when it's available.
Cool. Thanks, Matt.
Thank you.
Thank you.
Have a good one.
See ya.